Go.
Okay, this is day one for functions. We're talking about the coordinate plane and is it a function today. We're going to get into more advanced topics, but because today is test day, we're doing some basics today to get us started. So coordinate plane review. So the coordinate plane is used to plot points that look like this, x, y. And when you plot those points, you have to be aware of the different parts of the coordinate plane. So we have the y-axis that goes up and down, it's vertical. We have the x-axis that goes side to side. The origin is where those two axes meet at the very middle. And then the four quadrants are labeled in a counterclockwise rotation. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. I want you guys to see that these are Roman numerals, which is kind of odd. And that is the correct way to write it. So this is 1 in Roman numerals, this is 2 in Roman numerals, 3, and then this is 4. So formally, this is saying 1 before 5. It's kind of an odd way to look at it, but know that that is the symbol that means 4. Okay? So if I ask you where something is on the coordinate plane, I need you to be able to know where the quadrants are, where the two axes are, and that the middle is the origin. So again, x, y is what we're going to be plotting, and this is an important topic going into algebra. Two key words that I want you to know. A relation is just any set of ordered pairs, just a list of ordered pairs. A function is a special kind of ordered pair, and that list of ordered pair has only one y for every x. So what I mean by that is if I have a list something like this, we'll say 2, 4, and we'll say 3, 6, and 5, 9. Just making random numbers up. So for these x's, remember this first number is my x's. 1, 2, 3, and 5 are my x's. 2, 4, 6, and 9 are my y's. So for each x, there's only one choice of a y. So if I said you have an x of 1, that y pairing is a 2. You only have one choice, there's no other choice. This is a function, and it's considered 1 to 1. So just to make that make sense, let me give you an opposite choice here. So concentrate on your x's and your y's. So here's my x's. Looking at those x's, when I give you an x of 1, you have two choices of a y, a 2 or an 8. This makes it not a function. This one is a function. So for each x, for an x of 2, you only have one choice of a y. For an x of 3, you only have one choice of a y. For an x of 5, you only have one choice for a y. Over here, this is not a function because for an x of 1, you have two choices for a y. That makes it not a function. Do you guys see the difference between the two?
Yes.
So this one is just a plain relation. It's kind of a generic term for a list of ordered pairs. This one's a function because it's a specific kind of relation. Okay, let's look at some examples over here. So we want to know, is it a relation or is it a function? I want you to look at your x's. So on my x's, for each x, is there only one choice for a y? Is that true or is that false?
True.
So for an x of -2, how many choices do I have?
1.
1. For an x of 4, how many choices do I have?
1.
For an x of 5, how many choices?
1.
We have a function. Now, I'm only giving you a small list because I'm trying to be conscious of how much you guys have to copy down into your notes. Normally, you would have a bigger list of numbers, but I think 3 is enough for you guys to get the idea with our notes. Example 2. So let's look at our x's. For an x of 2, how many choices do I have for my y's?
3.
You got lots of choices. So for an x of 2, you have a choice of 3, 4, or 5. Is that a function?
No.
No, it is not. So this one is called a relation. Just a plain list of numbers. How about example 3? For an x of 5, how many choices do I have?
1.
One choice. X of 2, how many choices do I have?
1.
X of -3, how many choices do I have?
1.
So this one is a relation or function? It's a function. So I did these on purpose so that you guys don't get tricked when you see these when you're doing them on your own. It doesn't matter if your y's are repeated. It's the x's being repeated that should kind of trigger you to look at your y's, okay? So this one's a function. This one's a relation. It is not a function because for an x of 2, you have 3 different choices. This one is a function because for each x, there's only one choice of a y. Okay, one more thing. So we looked at, looks like my words got mixed up here, or got erased. We looked at a list of numbers and determined if it was a function. Now I want you to look at the graph and determine if it's a function. So keeping in mind the whole idea of for each x, there's only one y. Well, interpreting that into the coordinate plane, we can use the vertical line test to see if it's a function. So the vertical line test says if you draw a vertical line and it only touches the graph once, it is a function. So let me show you what I mean by that. And you can use your pencil and do this. So this is my pink line, and it kind of looks like a outstretched U. And this is a common, algebra kind of graph. If I take my pencil and I draw a line, how many times am I touching that pink curve? Once. So we're good, right? Anywhere I draw this line, I am only going to touch it once. It passes that vertical line test every time I draw the line. Do you guys see that?
Yes.
No matter where I draw that line, I am only going to touch that pink curve once. That means it passes the vertical line test, which means it is a function. Does that make sense?
Yes.
Look at the next one. Before I even draw a line, do you think this one's a function?
No.
No.
Right. So if you're not sure, use that vertical line test. Draw your line. Look, it fails. It touches it 2 places. That means that it fails. Now, just to be fair, and I want to make sure we're clear on this, I could draw a line here, and technically it would only touch it in one place. Great, but it fails over here. So it fails completely. Over here, it fails in so many ways that it's definitely not a function. It is a relation. So if it touches more than once, it fails the vertical line test, which means it is a relation. How about this last one? What do you guys think about it? Before we even use the vertical line test, what do you think?
Function.
Why?
Because there's not overlapping figures, like in the graph.
How about when we draw a line? Will it touch it more than once in any
No.
place?
No.
It should be very clear here, guys. When you draw that line, it's going to touch it only once. There's some examples that I try to avoid that might look something like this. We'll do this. In examples like this, sometimes it's hard to tell because you could probably make an argument and say, well, these arrows look like they're kind of going slowly out like this, but it's hard to tell. I try really hard not to give you examples like this because I think it can be interpreted a couple of different ways. Because in more advanced math classes, you could be going out so slightly that you can't really see it. So I would say you could probably argue either way for a problem like this. Whether you're seeing this as going completely up like this, or if it's going slightly out. So I try to avoid these kinds of examples for that reason. If you're not sure and it's not clear to you, we can always talk about it, okay? So vertical line test to decide if it's a function or relation. A list of ordered pairs to decide if it's a function or relation. And the coordinate plane with the quadrants, the axis, and the origin. That's what I want you guys to know for today, and we're gonna build on that next time.